Subset is any set that is contained in a set. So we can say that the subsets of B are itself. This is a subset of B. Also, subset 1 is also a subset of this because it is contained here. Also, 3 is also a subset. And finally, empty set is also a subset. So whenever you want to get a subset of a given set, these are the subsets. You have 1, 3, which is because we say that every set is a subset of itself. Then we have only 1, we have only 3, then we have empty set. So B is actually having how many subsets? It's having 4. So given any set, the number of subsets is known as the power of the set. It's known as the what? Power of the set. So how do you know the number of subsets for this? You simply count the number of elements that it has. Just do 2 to power the number of elements. So this is going to have 4 subsets. So let's say that you're given 1, 3, 4, and you're told to find the subsets. Without writing them one by one, just say 2 to power 3 because you have how many elements? 1, 2, 3. So it's going to have how many subsets? 6. So how do we identify these subsets? Once you already know that the subsets will always be 6, it's easier for you to write. So you can always know that every element is a subset of itself. So you have to write this first. Then you have to write only 1. Then you have to write only 3. Then you have to write only 4. That's how many? 1, 2, 3, 4. Then you have to write only 1 and 3. Then you have to write only 1 and 4. Then you have to write empty sets. So making it 1, 2, 3, 4, 5. Am I making mistake? Where's the mistake? 2 to power 3 is what? It's not 6. That's where the mistake is. 2 to power 3 is 8. You understand? Yes. So this has to have up to 8 subsets. So we have 1, 2, 3, 4, 5, 6, 7. So it's remaining 1. So we need to also have the subset of what? 3 and what? 4. So these are the subsets. You understand? It must have 8 because we have 1, 2, 3. It's going to be 2 to power n, which is 2 to power 3. So let's say now that we have 4 and 5, and we are told to find the power of this set. It's going to be 1, 2, 3, 4. So it's going to be 2 to power 4, which is what? 32. Huh? So if you build the subsets of this, you're going to get what percent? 2 to power 4 is 2 times 2 times 2 times 2. 2 times 2, 4, 4 times 2, 8. 8 times 2, 16. Sorry. So this should be 16. So if you build the subsets of this, you're going to get up to 16 subsets. So very important, take note. So that is how you get the power of the set. The power of the set is simply telling us the number of subsets that a set has. So all these are subsets of this because all these are contained inside B. 1, 2, 3 is already there. Okay, this is the one I was using. 1, 3, 4 is already there. 1 alone is already here. 3 alone is already here. 4 alone is already here. 1, 3 is already here. 1, 4 is already here. Empty set is the subset of every set. 3, 4 is already here. Every set is a subset of itself. So that is set theory. Make sure you understand. Every set is represented with a capital letter, and the content or the collection must be enclosed in a curly bracket, and the elements must be separated with commas. These are the elements. And subset of an element is another subset of a set is another set that contains the same element or that contains elements that are inside the main set. So this is the superset and these are the subsets. Power of a set is simply gotten by saying 2 to power the number of elements of the set. And the power of a set is also telling us the number of subsets that a set will have. The power of a set is telling us the number of subsets that a set will have. If you like this our video, please click on the subscribe button. Like and share it. Thanks. Hello, welcome. Today we are going to be looking at algebraic notation of sets. And we'll also be looking at the different types of sets where we have empty sets. Empty set is any set that does not have any element. Empty set. Finite set. Finite set is any set that the elements can be counted. Infinite set is any element that any set that the elements cannot be counted. And we also have the joint sets. Sets with elements that are not the same. Then we also have equal sets. Sets that have elements that are the same. So we'll be looking at all these today. Number one is algebraic set notation. If you look at these two sets, Q is a set of X so that X is prime numbers less than 25. And Q is a set of 2, 3, 5, 7, 11, 13, 17, 19, 23. These two sets are the same. This set Q and this other set Q, both of them are the same. Only that the first one is written in algebraic set notation, whereas the second one is written explicit. Is that clear? Is that clear? David, is that clear? What is the difference between these two sets? Good. This one is written in set notation, whereas this one is written explicit. So we say this is when elements of the set are not explicitly written. So whenever you don't write them explicitly, you write them in what we call algebraic set notation. Is that clear? And look at the way it is read. Q is set of X so that X is prime number less than 25. And you can see that all the prime numbers that are less than 25 are 2, 3, 5, 7, 11, 13, 17, 19, 23. So in subsequent classes, I will be giving you assignments. I will write in algebraic set notation and I will require you to write it in the explicit form. You understand? Now check out this second one. F is a set of X so that X is a member of integer. And this integer ranges from 5 to 14, with 5 and 14 inclusive. Is that clear? You see, the representation is all the integers from 5 to 14, and you know integers are whole numbers, isn't it? So we have 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Why is it that 5 and 14 are included? Because we have equal to sign. If there was no this equal to, if it's just less than, we would have had from 6 to 13. Is that clear? But whenever you have equal to, it means that the extremes are included. You understand? Between 5 to 14. Is that clear? So this is what we call algebraic set notation, and this is the explicit form of writing the sets. You understand? So these two sets are equal. These two sets are the same thing. Only that one is written in algebraic set notation, and the other one is written explicitly. Is that clear? Now we look at the types of sets. An empty set is a set without any element. An empty set is a what? Any set that does not have any element. This is how you say this is an empty set. Is that clear? What's the difference between this set and this set? This other set, this is not an empty set because it has element what? 0. This is what we call empty set. Set without anything. Another word for empty set is null set. Another word for empty set is what? Null set. Finite set. Finite set is any set that has elements that can be counted. Is that clear? Finite set. Any set that has elements that can be counted. Like set of local governments in Nigeria. How many local governments do we have in Nigeria? 774. Is it not? So it can be counted. So it's a finite set. Give me another finite set. Number of people in this class. You can count yourself, isn't it? But if I say set of odd numbers, is it finite? There are plenty of numbers you cannot count. So any set, any elements of set, any set that has elements that cannot be counted is known as infinite set. Like set of odd numbers, set of multiples of 9. This joint set, when you have two sets and they have no elements in common, we call them disjoint sets. Is that clear? Example, set R has elements ALM and set Q has elements RKD. Is there any set in common? Is there any element in common between these two? So this is members or elements, even if they are not written in the same order. Can you see set C? What are the elements of set C? 1, 3, 4, 7. What are the elements of set B? 3, 7, 1, 4. Why are they equal? They are equal because they contain the same elements. Can you see? There's 3 here, there's 3 here, there's 1 here, there's 1 here, there's 4 here, there's 4 here, there's 7 here, there's 7 here. But they are not arranged similarly, you understand? But they are still equal. So you can write that C is equal to B. Is that clear? So I'm going to be giving us this exercise in set notation to see how we are able to understand set notation, set or direct notation. Is that clear? So we're going to be doing some examples. Now I'm going to require you to list the elements of the following set. Prime numbers less than 30. List me the elements of this set. Prime numbers less than 30. That's assignment number 1. Number 2, factors of 24 greater than 3. List me factors of 24 greater than 3. So list it explicitly. And finally, R is element of S so that R is element of S so that X is a member of N, is a member of N, and is between 4 and 20. So what question are you supposed to ask me about N? You're supposed to know what N stands for. You can tell me what N stands for. Alright, let me just say Z, the one I've told you already, so that later I'll tell you what N is. So represent it such as X, please put S here. So give me these sets explicitly. In subsequent classes, we'll look at them. Please, if you like this our video, click on the subscribe button, like and share it. Thank you. God bless you. Hello, welcome. Today we're going to be looking at the different relationships between sets. Different relationship between mostly two sets of any number of sets. Number 1, we're going to be looking at intersection of sets. When you have set A containing elements like 1, 2, 3, 4, 5, 6, and you have set B containing elements like 3, 4, 5, 6, 7. The intersection of set A and set B is simply the elements that are common to both A and B, which is 3, 4, 5. Intersection of sets is represented as A, this is set A intersecting set B, is a set that contains all elements common to set A and B. Example, when you have set A containing 1, 2, 3, 4, 5, 6, and you have set B containing 9, 6, 4, 8, 10, 12, then set of A intersection set B will be 4 and 6 because 4 is in A and 4 is in B. 6 is in A and 6 is in B. That's why the intersection is only these two elements that they have in common. Number 2, we look at union of sets, represented as A, U, B. Set A, union of set B, is simply the set that contains all elements, set A and B, without repeating. So if you have set A as A, B, C, D, E, and you have set B as E, A, E, I, O, U, then set A union B simply, you write out all the sets A, B, C, D, E. You continue here A, but you already written A, so you leave it, don't repeat it. E, you already written E here, don't repeat it. I, you write I. O, you write O. U, you write U. So it's simply the collection of both sets here and here, but don't repeat without what? Repeating. That is A union B. Now, universal set. Universal set is represented with U or E, capital letter U or E, and it's actually the background set. You understand? That contains all the sets that you're considering at the moment. Like say you're considering this set M that contains 1, 3, 5, 7, 8. And you're also considering set N that contains 1, 2, 4, 6, 8. What is the universal set? Universal set is simply like a union set of these two. So you have 1, 2, 3, 4, 5, 6, 7, 8. Combination of all the possible sets. When you combine them, you form this. So that you can now talk about complement of sets, which is complements of sets is actually the elements that are not in the set that you're considering, but are actually in the universal set. So let's say complement is written, you represent it by prime or small c at the top. So complement of set M, this is set M, 1, 3, 5, 7, 8. What are the complements? Complements of set M are those elements that are in the universal set, but they are not here. Like here you have 1, but you don't have 2. Because you don't have 2 in M, you put it here. You don't have 4 in M, you put it here. You don't have 6 in M, put it here. So those sets that you don't have in M, but you have them in the universal set, they are the complements of M. The same thing, what are the complements of N? Those sets that are not in M, but they are in universal set. Like here, 1 is here, so you don't, 1 is not. There is 3 here, but there is no 3 here, so you write. There is 5 here, but there is no 5 here, you write. There is 7 here, but there is no 7 here, you write. So complements of N are those sets that are in the universal set U, but are not in N. Now we look at difference of a set represented as A minus B. Difference between set A and set B represented as A minus B is simply the set of elements that are in A but are not in B. So if you look at these are the sets of elements in A, B, C, D, E, F. And these are the elements in B, B, D, E, G, H. What are the elements that are here but are not here? You see that they are A is here but it's not here. C is here but it's not here. F is here but it's not here. So A minus B is this. But B minus A are the elements that are in B that are not in A. So if you look at A, B, what are the elements here that are not here? Talk about G. There is G here, but there is no G here. Talk about H. There is H here, but there is no H here. But then you can see that A minus B is not the same thing as B minus A. Can you see that? They are not the same. So you have to do it carefully. Please, if you like this, our video, click on the subscribe button, like and share it. Thanks for your subscription and everything. So meet again. Thank you. Hello, welcome. Today we're going to be looking at Venn diagrams. We're going to be looking at what? Venn diagrams. Venn diagrams are shapes that we can use in explaining the relationship between sets. They are what? Shapes that we can use in representing the relationship between what? Sets. Is it? In our previous classes, we looked at a set and we said that every set is represented with a capital letter, is it not? Then on the other side, it is represented with elements that are enclosed inside a curly bracket, is it? Now we're going to be representing every set with a circle, with a what? Or a sphere. And we are going to be representing the universal set with a what? With a what? Rectangle. With a what? Rectangle. So anytime you're representing sets with cycles or spheres, and you're representing the universal set with a rectangle. We'll call that such representation what? We'll call it what? Venn diagram. So Venn diagram is a geometric interpretation of sets using diagrams which shows different relationships between them. So this is a what? What is this? And what does it represent? Universal set E. Is that clear? And this circle inside it is a what? It's a set. It's a what? Set of what? P. It's a set of what? P. And we say that anything that is in P, anything that is in the universal set, but is not in P, is known as the complement of all these other ones, apart from the P, is the complement. Is that clear? And we can also say that P is a subset of the what? Universal set. Because P, this circle, is contained inside a block known as the universal set. Is that clear? Present subset like this. P is a what? Subset of what? Universal set. Then we look at this. The dotted portion is the complements of set what? P. Can you see the dotted portion? These ones. Why is it the complement of P? Because it contains the elements in the universal set but that are not in what? P. That's why it is complement. Now this relationship, what is it called? It is called the intersection. Is that clear? P intersection what? Q. Why? Because it's telling us that when P and Q are together, this is the only portion where they share together. Is it not? That's the intersection. Then this one is showing us the that are not in Q, and that is the difference. Is it not? That's what we learned before. Difference. P minus Q. Or you can also call it P intersection Q prime. Now this relationship that everything inside is shaded is showing us the union of P and Q. Is that clear? Shows us P union Q, written as P union Q. This relationship where the two sets are separate, what is it called? Disjoint set, because they don't have anything in common. Unlike this one that has something in common. This one they are separate, their elements are separated. What of this relationship whereby a set Q? Hello, welcome. Today we're going to be looking at the relationship between three sets. Between how many sets? Three sets. And we say that every set using the Venn diagram representation is normally represented using a what? And the universal set is represented using a what? Rectangle. So this is three sets. Can you see the set once? The first set is known as set what? And the second set is set what? And the third set is set what? Can you see where the three of them, did the three of them join here? Yeah. Did the three of them join here? No. Here is only which ones are joining. A and one B. Here, which ones are joining? Around what? B. Here, which ones are joining? Around A. But inside here, how many are joining? Three of them. So this point where all of them are joining that is shaded is known as what? R intersection K intersection what? B. Can you look at this set? Which of the sets are joining in the shaded portion here? K and P, is it not? So the shaded portion is where K and P has the same element. And it is represented as K intersection what? P. Can you see K and P, they are intersecting? Now intersection of what? Non-R. Non-R. Is that clear? Because everything here is not inside R. Can you see that? Because this is R. Everything here is not inside R. So that's why we are using R prime. Is that clear? Now what are we having here? We are having things that are only in P, but are not in Q, and things that are only in R, but are not in K and P. Is that clear? So we call it R intersection, not K. You understand? K prime simply means not K. So if it is not K, it has to be around R, is it not? Intersection not P or P prime, which is here only. Is that clear? Now if you have all the three of them shaded, we have R, we have K, and we have P. All shaded, we call it what do we call this? R what? Union what? K union what? P. Is that clear? What if we have all of them separated? We have what we call what? We have what you call what? Disjoint. Is that clear? So this is how you represent sets, very important. Now, before we move on to the example, to represent two sets using the two sets and the three sets, and you're going to tell me where and how to label each. Are we looking? Anu, are you looking? This is the first one. Is that clear? And this is the what? Second one. Here we have sets and we have this. We have P and Q. And here we have three sets. And we have R, O, M. Is that clear? Now tell me where I can represent P union Q. Okay, let's start with intersection. Where is P intersection Q? Where is it join? Where is it? Inside here, is it not? So inside here we can represent what? P intersection what? Q. Is that? Where can we represent only K? Only K will be here, right? Is that? Is that? Now we will represent only P. Where do we represent the M intersection? This should be capital letter bar. M intersection R intersection O. Where should that be here? Middle, isn't it? Where can we have M intersection O intersection R prime? Down part. Where? Thank you, that is here. Is that clear? Where can we have R intersection M intersection O prime? Here, ma? Is that clear? So very importantly, you need to know where to find each one. You understand? Because we are going to be using this to solve real problems in Venn diagrams. Okay? Because if you like this video, click on the subscribe button.
Hello, Emmanuel. Good afternoon.
Hello, welcome. We said that when we want to represent